Hello, everybody. We have a great episode today of Building Energy. So, this one's a little bit unique. So, first off, we're going to have Chris Colwell. He is the president of Global Utility with Valmont Industries. And then, second up, we're going to have Danny Lonergan. He will actually be on site at the Utility Expo. So, first, Chris, welcome to the show. It's great to have you on. And let's just probably get into just a quick overview of Valmont Industries and what you specialize in.
All right, Rory. Well, thank you. First of all, thanks for having Valmont join this morning. We are very appreciative of that. Um, a little bit of background on Valmont. First of all, Valmont is a company that really focuses on conserving resources and improving life. So all of the products that we produce center around that. We have two major segments in our business. One is irrigation products, and the second is infrastructure products. And so my group is part of the infrastructure products group. With respect to improving life, from an irrigation standpoint, we improve agricultural productivity. From an infrastructure product standpoint, we have multiple different product types. So telecommunications ensures reliable connectivity. Our lighting and transportation business increases safety and efficiency for our roads and public spaces. And then within my segment of the business, we create utility structures that ensure a stable and reliable energy supply. So we're the ones that build the products that create the highway to move electricity from the generation source all the way through to the end consumer. Valmont also has a solar tracking business, so we do some work on the generation side of the business. And so we really encompass all of the critical infrastructure that helps to make people's lives in North America and across the globe.
Okay.
I'm sorry.
Oh no, I was just going to say that's fantastic. So yeah, if you can get like on that product side, yeah, if you could just unpack that a little bit more, that'd be fantastic.
Absolutely. So within the utility segments products group, we produce the vital infrastructure that supports products that enable the delivery of reliable power to the world. So we're moving that power. Specifically, we produce transmission, distribution, and substation products. So the substation products convert that electricity from the generation source. We transmit it across very large transmission structures, ultimately then converting it back down to distribution structures that help to deliver it to the end user and the customer. In addition, we also have inspection services to help to ensure that that grid remains reliable, remains intact. So combining all of those things together, we bring it all to a place where we make sure electricity gets delivered to everyone.
Okay, and with Valmont, do you have a long history in the utility segment as well, or has this been being added on as like you hear a lot about like the infrastructure bill in the USA, but is this something you've been specializing in for a number of years?
It is, Rory. Yeah. So the business started with our irrigation business, but we have been doing infrastructure utility products for 50 years plus. We've been doing it for
Okay.
many, many years. Very entrenched in the industry. Recently, we have purchased a solar tracking business that now we have had for 3, 4, 5 years. I'm not quite sure how long, to be honest.
Okay.
But now we're on that generation side as well.
When you say I just want to touch on that a little bit. Solar tracking is a different. I haven't actually heard that term. What does that actually mean?
So you have solar panels that are collecting the electricity from the sun,
Yeah.
but the tracking structures are what they sit up on top of. So the trackers then follow the course of the sun so that it's very efficient electricity production because you're getting
Right.
the full effects of the sun. So we're creating that product that these big panels sit on.
Okay, fantastic. So I feel like I've seen actually some of the videos of that. So it's each day that just follows the sun. Right.
Exactly. Yeah, it just tracks the sun from the morning until the evening. It tracks the course of the sun to make sure it's getting as much consumption of that electricity as it can.
Okay, great. So yeah, and then back onto you said like the infrastructure for these utilities. So I mean, I just drove down from Kamloops, and I always see when you're driving down, you always see these gigantic high voltage power lines. Well, I think they're high voltage.
Yeah, no, they are.
Okay, and so I see these giant structures. Is that you would be manufacturing those then for customers all across North America then?
All across North America and the world, yeah. So we sell products into Canada. We sell products throughout the U.S., Mexico, and globally. So we're selling products everywhere. The structures that you're talking about are very probably transmission structures, transmitting high voltage electricity.
Right.
And depending on the span and the distance, those structures can range from a couple of feet all the way up to literally 15 feet in diameter. They're massive.
Oh, really? Oh, okay. That's okay. That's massive then. Um, the Are you seeing on that transmission side and on those products with the, I mean, you again, you see like people talking about aging infrastructure. Has there
Yeah.
been a lot of development and innovation now behind those products as well, as we kind of in say like the past decade or 2 decades?
Yeah, absolutely. Everything we do, we work, it's almost constant innovation. As for our business, what we do is custom engineered products. So everything that comes in is a specific to the project in terms of the specifications that are needed and required. And so from an engineering perspective, we're innovating everything from the connection points of all of the arms that sit on these structures to the foundations to the material types. So it's really constant innovation to make these structures as strong as we can make them, as reliable as we can make them, as cost effective as we can make them.
Of
So,
course.
the innovation, it's not points in time. Literally, it's every project that we're working on is uh, customizing that design to be as optimal as possible.
So, and is that so state by state? Let's just using the USA as an
Yeah.
example. Are you there's a lot of different utility companies down there. So
Right.
I guess it probably, do you find it's different for each utility company based on like the location and everything as well, even if it's the same
Yeah.
product?
Yeah, good question. First of all, from a regional standpoint, there's a lot of regional requirements, certain soil conditions, various
Right.
wind conditions, whether or not it's mountainous, and then every utility has their own standards. So they all have a different approach that they use to produce their or to put their products in the ground and what they require. And so there is no one size fits all. And so what we will do is working with these individual utilities is understand the requirements from a load standpoint. So what are the load factors on these structures? And then what are their standards? And then we design to those standards. So we're very, very closely integrated with our customers' engineering groups.
Okay. Yeah, engineering must be a huge part in all this, so that you probably work directly, like your engineering teams, I would imagine as well, they work directly with those utilities too.
They do. Our business is very much an engineering driven business. And so, when we think about our customers, we'll do business with plus or minus 100 customers in a given year. But really, there are a handful, literally 20, 25 customers that represent the vast majority of the volume because they're just huge utilities that span across the U.S. And so it's a very limited focused customer group. And then within those customers, our engineers are very much embedded with them. So we have engineers that have, in some cases, worked with these customers for 30 or 40 years. And we speak their language, they speak our language, and we interact. We have about 94, right now, I think 94 engineers and drafters in our business,
Oh, okay.
and they're the ones that are connecting in. So it's just, it really is kind of the heart of what we do.
Okay, excellent. And we did touch a little bit on the aging infrastructure. Are you seeing with electric transmission, are you seeing other market drivers as well? Obviously, one you hear the term renewable energy. Are you seeing that having an effect as well with Valmont?
Absolutely. We have really three or four major drivers in our industry, starting with reliability. The grid that is in place today has been out there for 50 years plus. It's been out for many years, and much of what has been built really wasn't engineered for the current reliability standards. And so as we are seeing changes in the weather and in this aging infrastructure, reliability is a huge driver for what we're doing. Not only is the grid aged, and so it's just getting older,
Mm-hmm.
but also then the weather impacts, whether it be hurricanes down in the Gulf Coast area, or fires in California and now Hawaii, you see,
Mm-hmm.
or in Canada, as you see.
Mm-hmm.
The reliability of making sure we get electricity from point A to point B is critical, because when that electricity is out, people die. And so that's a major part of the driver. In addition, the renewable generation is a massive driver. Every one of the new renewable generation facilities, whether it be solar or wind or hydro, they all need to be connected to the grid. Historically, generation was built around coal
Yeah.
generation. And that was much closer to the point of contact where the consumer was using it. Today, solar is in regions that may not be close to where the consumption is. So the infrastructure of transmission needs to be put in place to connect that generation to those end users, and that doesn't exist today. So it's a massive build out of what is required going forward. To put it into perspective, right now there are about 200,000 miles of high voltage lines in North America,
Okay.
and about 5.5 million miles of distribution lines in North America. And as we look forward, that is going to more than double to be able to
Really?
support the renewable push that's coming online. It's massive.
I have a question. Well, hopefully it's not too off topic on the solar. So when you're saying like with back when there was a lot of coal power generation, it was closer to the source, meaning
Yeah.
like if you're getting to the industrial areas or like even like homes, it was going to be closer. When you have solar and renewable, are you seeing more where from the source it has to be stored? Like, is there being storage like from battery and then that has to be transported? Is that a thing that's going to be happening more and more as the renewables come online?
It definitely is, Rory. Historically, when generation started, it was very localized, literally serving a couple of thousand people. And then as that expanded and coal continued to be utilized, it remained close to the cities that was consuming it. It was very much at point of contact. Solar is an example. It's much more prevalent in the Southwest. And so you have to move that electricity. And so how can you do that? And then with solar as a good example, when the sunlight is out, it's generating electricity. But in points where the sun is not shining, you have to be able to store that electricity to be able to use it later.
Yes.
And so not only do you have to get that electricity transmitted, but you also have to have the storage. So battery technology is a critical component of the shift to renewables, as is any other way that we're working now to store this electricity. The same would go for wind. When wind isn't blowing, the electricity stops. So you have to be able to store some of that. So it's really not one thing is critical. There are multiple things in the system that is needed to come together to make this happen as we look forward to the future.
So for Valmont too, with all this transition into the renewables, that's got to be good on your end because, like you said, so now I'm gonna mix up. I think you said there's 500,000 miles of high voltage line in the U.S. already.
200,000 miles of high voltage lines approximately,
200,000,
and
okay.
5.5 million of distribution. So you can imagine, as we look forward, the power sources are becoming more renewable.
Yep.
And in addition, they're shifting towards electricity. So when you look at, for example, electric vehicles, we actually saw a decrease in electrical demand over the past 20 years. We're seeing that now reverse, and it's expected to more than double the demand of electricity in the coming 30 years. So between now and 2050, it's going to more than double, and so is renewables. As a source of electricity, it's going to more than double on that front, which means a massive need for all of the ways to get that electricity to those end consumers because they need more of it.
Yeah, it's almost, I guess for each, you have to go state by state and like region by region, because if you think of it on a whole, it kind of becomes mind-boggling. To me, it's like that's a massive number, but it's kind of a slow build as more people even transition into driving electric cars, right?
Yeah, it's almost exponential. It starts slow, but as electric vehicles are adopted, as new data centers go in that require electricity consumption, all of those types of things, it just builds upon itself. And so the more electricity consumed, the more that you need, the more adoption that occurs. And it's just this, we're in this super cycle of electrical or energy transition for the first time ever. I mean, even since electricity was developed, it's just a massive shift that's occurring, and it's accelerating, and the resources needed to support this are immense, and the magnitude of what's required is immense.
We'll actually get into that with Danny a little bit more on the product side, but that must be a big part of Valmont's supply chain, is being able to bring in all the right products for developing these, especially like if you go into California or British Columbia, is there like a main, I imagine that's increased is it metal poles for that? Like, is that a big challenge on the supply chain?
Yeah. So if you think about those drivers that we talked about, for example, the reliability, depending on where you are, it's going to require a different solution. And so as an example, if you're in the state of California and you have fires and you need to ensure a reliable grid, Steel is a good solution to help to harden that grid because most of that distribution network is wood. And so with steel, you don't have the same impact of fires on the steel. In addition, you could say the same exact thing for composite materials. It does very well within fire prone areas.
Mm-hmm.
However, if you have a same situation, let's say there's a mountainous terrain, that's an area that you would not want to put concrete in. You want something much lighter. And so we'd choose a lightweight material for that solution to be able to get those structures into the mountainous areas that you've got. So, and in other examples, for example, the Southeast, you have a very different soil type, and you also have a lot of salt impact. So steel isn't always the correct solution there. Their concrete products are a much better solution because it withstands that environment. So part of what Valmont's strength is and part of what we do is we bring together all of the technologies, all of the materials to bring these products to market specific for the solution that is needed. And in some cases, then we'll blend them together. So sometimes it's a hybrid solution where we bring multiple material types to address the need at hand, make sure that that grid is as reliable and strong as we can, given the conditions. For example, down in the Mid-South with the hurricanes that come through, a very different situation. I'll talk about larger transmission structures. Innovation in that, monopoles, they needed to withstand 190 miles per hour winds.
Right.
And so we innovated with products that are staggeringly large. And instead of a one-legged structure, they're four legs to make it be much more efficient from a load standpoint, withstand the wind, but also much cheaper foundations because the foundation costs for the project people putting the projects in were immense. And so that kind of innovation then addresses a specific need for the task at hand.
When did you realize, like, for that the four-legged pole, when was that developed? Like, has that been around now for several years or decades?
It has. I'll tell you, we had some very smart people design this, and it was highly complicated. And over the past decade, it started with three-legged structures for certain customers in the Midwest, and it expanded to four-legged structures. And it probably took 2 years of engineering on paper to come up and prove the concept. And then there was a tremendous amount of physical testing where you would produce the structures and put them on massive test stands to provide the loads required to see if they actually worked, if the engineering design actually worked. And over this period of time, 3-4 years of development, we finally then brought this to market on very limited basis for certain specific applications. And over the course of time, it's now really been deployed across the nation wherever those types of conditions exist.
Do you actually, like, from Valmont being a giant player down there in the utility sector, do you find, like, when you have these new products, it almost becomes like its own, like, business within the business, and then you like almost having to get it to market?
Yes, very well said, and very insightful, actually, because when I came to join Valmont, I didn't come from the industry, and I thought, it's a pole. It's not a pole. They're very different products, and they're very different, unique manufacturing processes and unique markets that you're selling into. So really, when I talk about transmission, distribution, and substation, you can think of those three pieces as individual businesses because they require very different manufacturing, very different end users, very different approaches to go to market. So the answer is yes. We do have dedicated substation teams and businesses. We have the same for transmission, the same for distribution. And in a few minutes, you'll talk to Danny Lonergan. Danny is the leader of the distribution business, so that's where he fits in the puzzle.
Oh, okay, perfect. Yeah, we'll really pick his brain in that segment too. And then I guess the other big thing that is you touched on as well, that manufacturing capability that you have paired with the engineering, that must be a huge motivation for the utility companies when they're coming to Valmont as well, I would presume.
It is, Rory. In our business, it is a business of large projects. And so we don't go and proactively sell a transmission structure. It's dependent upon the project. And so the project drives that demand. And so given that, when we're looking at our customers and we're looking at what is out there, the transmission piece, again, as an example, is about risk mitigation. Because these projects are so large, I'll give you an example. I won't name the customer, but there was a customer in the Mid-South that historically $5-10 million a year of volume. And then they had very large data centers going in and large electrical consumption that they needed to run transmission to. The
Okay.
volume of their business changed in 1 year from 10 million to $150 million.
Wow.
So huge projects. And it's all about risk mitigation, because when you're putting these size of projects in, you have thousands of people on the construction side of the business that are there waiting to receive materials so that they continue to put these structures in the ground.
Right.
If, for example, it's between New Year's and Christmas, and you have 100 people waiting for product to deliver, waiting for that structure to deliver, if you're not reliable, they are sitting there over the holidays waiting for something and away from home, oftentimes in the middle of nowhere. And so this risk mitigation factor is really what we're selling our customers. And for Valmont, we're reliable. We have 19 facilities in North America alone, very, very large facilities. As you're building these products, as you're bending the steel to make these structures, if one of your brake presses go down, as an example, that could put you out of business. Valmont, having 19 facilities, has multiple redundant systems so that if we do have issues, we have solutions sitting in another facility that we can shift these projects to keep things going. So, the amount of money our products represent about 15% of the project cost. So the vast majority of the project cost sits in that construction side.
Right.
If we're late, they're losing money and they're spending money. And so we have to make sure that doesn't happen.
Yeah, that's a really good point, especially it seems like too there's a big for the supply chain again being able like it sounds like you have very strategic locations with those 19. It makes everything go much smoother when you have things being delivered on schedule.
Always a bit smoother when it's on schedule. It's not an easy thing, and I wouldn't be white-headed if I told you otherwise. Sometimes it's a challenge, but that's okay.
Yeah, just to before we go over to Danny's segment, what are you seeing as like the major? I mean, you've touched on them already, of course, but just on the wrap up, what would you say are like the biggest market needs that you're seeing coming online in like the next 10, 20 years, and also and just to recap those solutions?
Yeah. So, again, what's driving this is those three major drivers. The aged grid is out there, and in some cases, it's been out there much longer than it was ever intended to.
Right.
And so that reliability becomes critical. That is a driver. It's not going to go away over the next decades, multiple 20 years, 30 years. That it must be replaced. The renewable shift is another major driver, because you can build all of the solar and the wind that you want, but if you can't connect it to the people, it doesn't do any good. So that highway system between must be put into place.
Mm-hmm.
That's a major driver, and those aren't going away.
No.
And then the reality is the world environment is changing, the weather is changing, and with that comes unpredictable things such as the fires and the storms, and all of that puts pressure in those areas to make sure that grid is reliable. So that's the answer in terms of what do we see driving the business for the next decades. Very simply put, these drivers are here today and they are not going to go away. The magnitude that needs to go into to provide a solution is immense. Our solutions are that risk mitigation and innovation. The risk mitigation because we can build the products and customers can count on us to deliver these massive volumes of products as you can imagine.
Yeah.
And in addition, then the engineering innovation, because we are, there are not many companies, none, that can bring all of the different material types to bear with the engineering that goes with the innovative products to give the customers the solutions they need, because one size doesn't fit all.
That's a great answer, and I almost wanted to. As you were saying that, I just realized when you're saying about like the changing climate impacts and everything, one thing that stands out, and I'm just going to add this in because it's interesting, I think, and I'd like to get your perspective. You're talking about moving a lot more power from these more remote locations, right? So that's where probably a lot of the innovation has happened as well, I would imagine, with the products, because like you said, you're going through mountainous terrain, you've got more going through like very remote areas, which I just realized when you're saying that, that's going to happen more and more as there's more data centers, as there's more like electric power, right?
Exactly. All of those drivers that I talked about with the, kind of the external, but the one thing that's really changed is electrical consumption. And so with electric vehicles, it's staggering to imagine how many locations are going to need to be able to power these vehicles. And in doing so, they're all going to need connected. They're all going to need some type of substation. They're all going to need a new infrastructure of electricity to get them there. The data centers, Bitcoin is a massive consumer of electricity,
Right.
so that's coming on board. Microchips, so we're doing more manufacturing in the U.S. Some of these facilities are just massive, and the electrical needs there are massive, and cities, communities don't have that infrastructure today. So we're building special dedicated infrastructure to get it to some of those manufacturing facilities such as microchips to
Right.
get that electricity to where it needs. So yeah, it's the demand itself is creating another major driver in addition to all of those other external factors.
Great. Well, I could ask you a whole bunch more questions, but we'll have to leave it there. Chris, thank you so much for joining on the first segment. We're going to now move to Danny, who is at the Utility Expo. So again, thanks for joining, and we will, of course, in the description, everything, we'll put all the links so people can connect you, find you on LinkedIn and everything. And yeah, it's great to learn on. It's great to learn what Valmont is bringing to that energy transition.
Awesome, Roy. Thank you. Thanks for having me.
Okay, so we had a great first segment there, and now we are going to Danny Lonergan. He is at the Utility Expo. Great to have you on, Danny. And if we can just jump right into the distribution products and kind of a quick overview of the grid hardening. I mean, it doesn't have to be quick, but that would be a great start. And of course, welcome to Building Energy.
Great. Thank you. My name is Danny Lonergan. I'm the Vice President for Distribution, covering all product management. So what Chris covered was a lot of custom transmission, custom designs. We spoke about engineering and that interface and partnership between our customers and ourselves to design very specific structures for use. I'm more in the standard structure space, what is commonly called poles in the industry,
right?
Which we call catalog poles. The industry calls class poles, but the takeaway is they are pre-designed structures. They go through that same process of engineering and validation, through software and test, but the end result are quote unquote catalog poles. And we have those available in all three materials as we covered with Chris in the previous segment: concrete, steel, and fiberglass. So what we want to do today is just really talk about those three different materials, spend a little bit of time on how they're produced, and then to Rory, your question, how they're actually used geographically across the country. So each material has, if you will, a benefit and possibly a negative. But when we look at all three materials collectively, they provide a pretty positive solution for any given customer in their geographic space and what they're trying to resolve. So to the hardening subject, that's a solution for the utilities, and it's usually a decision they need to make to repair or resolve something that's not working. So historically, wood has been the backbone of lower voltage, what we call distribution. Again, a lot of what Chris covered was transmission. If you look behind me, to my left and to my right are transmission and substation. So I'm in the middle here for this video, really talking about what we refer to as distribution, and it's commonly class poles, wood conversions, excuse me. So geographically, different parts of the country like materials over other materials.
Right.
So what I was going to do is just kind of pan across the country, Roy, and kind of highlight where certain materials are used and why they're used.
Okay, that'd be great. Let's probably jump into let's go into the concrete first and cover that segment and kind of like you said, the material advantages, where they're being used, and even if you have some use cases, that'd be excellent as well.
So what we showed earlier was some drilling of concrete. So we have an outside display here at the utility show to show the hands-on. But concrete is manufactured in a similar fashion in all our facilities, whether the pole is large or small, meaning tall or short, and high strength, low strength, and in its capacity. So they're primarily historically used in areas around oceans and the Gulf. So when you look at our facilities, they're really in challenging areas where steel may not be the perfect solution. So Chris commented on that subject of corrosion. So often customers choose concrete where it makes a better solution. That's why our facilities are near water. So anything that has to do with seawater in the water, physically in the water, that's a great application of concrete. Another positive of concrete is we can design them to do exactly what is necessary, whether they're class poles or stronger class poles. Generally speaking, concrete is used in tough environmental locations, near sea areas, physically in the water, extreme wind, events like that.
That makes a lot of sense.
Primarily in
Oh, oh,
go ahead.
I was gonna quickly jump in there on like with these concrete poles now. Are they seeing like really long lifespans as well? Even like because they're being used in these potentially high corrosive areas. Do you get a lot of longevity out of each one?
Yes, we do. So historically, spun concrete, which is the manufacturing process we utilize, has a history of about 100 years of application. So, and that 100 years dates back to really Europe. So that the spinning technology, and we'll cover that a little bit on how we produce the product, but that yields a very, very high performing product, which is very durable and useful over time. So in North America, the spun concrete product has been in existence for about 60 years, being introduced in the early 60s. So generally, all of those products are still in service. Where they've been put and the reasons they've been put there are for durability purposes. So the duration or longevity of any of the engineered materials generally are much better than that of wood.
Yeah, that's I wasn't expecting 100 years, honestly. So that's pretty incredible. And then, of course, yes, like you mentioned, we captured the concrete drilling demonstration. That's kind of an area where sometimes it can seem like it's going to be more challenging, right? But it's as you demonstrated, it's actually can be done pretty effectively and efficiently.
We can. The key to drilling, field drilling, was what we refer to it. When we work with our customers, honestly, we do as much drilling as we can for them in the facilities because
Okay.
we're much more effective doing it at the factories, regardless of material, than the customers are. Just from an economic benefit, we're equipped, we're tooled, we have work cells to do that. But inevitably, especially in lower voltages, the unknown exists because again, you're going back to a catalog pole that's generally an inventoried item. The customers work through a process to have as many factory drill holes as possible, regardless of the material, but inevitably they have to do something in the field. So all the materials are managed differently in the field. And what it boils down to is tools and equipment. So what we saw in the video was basically a hammer type drill with a carbide tipped concrete bit. So if you were to take the equipment used for steel and try to use it on concrete, it would be ineffective. If you were to take the equipment used on wood and try to use it on concrete, it would be ineffective. So the takeaway for all the materials is they each have a different type of cutter, and it's a speeds and feeds activity. So in our facilities, we utilize the same kinds of drill bits, if you will, or cutters. Just in the field, we use manual equipment as we showed you. So, but to your question, it's not difficult. It's perceived to be very difficult. But once you understand the guidelines and we walk you through the instructions, it's literally less than a minute.
Oh wow!
The hole
okay.
in a concrete pole. So what you saw in the demonstration was probably about a 2.5 to 3 inch thickness of concrete. So if you think about that, and we did it in less than a minute, it's very doable.
That's fantastic. So you've gotten into that. I probably let's jump into the steel products as well, and some of the advantages to those that you see for your clients using those now.
So for steel, again, it's a catalog product, pre-designed. It all has a classification in our industry. But what that means is a strength of pole. So the users choose the poles to their application, to their known strengths. The key difference between steel and concrete is the thickness and, frankly, the weight. So a steel pole is much different and a much lighter weight product and provides a different opportunity and a different solution for a customer. So whereas in concrete, it may be a coastal delivered from the facility to a production site, steel presents a different opportunity where it's lighter in weight, it's thinner in gauge, and we can put many more on a truck, and we can effectively deploy them in more opportunities, more places. So the real takeaway for steel is it's roughly about half the weight of a wooden pole.
Okay.
whereas concrete's about twice the weight of a wooden pole. When we're referring to low voltage, quote unquote, distribution applications, so each ultimately are the same strength, and the designer chooses a pole based on the strength requirements, meaning loads and their overload factors. But that's the key difference between steel and concrete, frankly, is the thickness, the material, obviously, and then the weight.
So with this steel, then are you seeing more and more of the wood being replaced by the steel poles now? Is that going to be? Do you think eventually it'll be fully transitioned from wood poles to? Well, you've talked about concrete, but a lot to the steel products.
We're definitely seeing a trend over the last 10 to 15 years. So from a steel perspective, tubular steel has been in place for about that 60-year mark as well.
Okay.
When we think of high voltage transmission, tubular steel, it's again since the 60s or that 60-year mark. As we move into lower voltages, which is more of a wood conversion, has been more of about a 30 to 40-year cycle, meaning we've got product out there that long. So ultimately, the conversion from wood to non-wood, the percentages grow year over year over year. There's a lot of volume out there. It's probably unrealistic to think that non-wood products will 100% place wood, but we're definitely seeing the trend moving more and more towards an engineered structure. The project helps that. So the trend is moving that way. But the industry is predominantly wood right now. As we move forward in time, we'll see more steel, concrete, fiberglass, and/or blends of all those materials used in service.
Right. And on the just before we move into the fiberglass, is there any use cases that would stand out that are using that maybe even like they moved from like a wood product or a different product to the steel and saw great success? Is that happening quite a bit now?
It is out west. There's two applications that have really carried that 40-year cycle that I just described. Out west, most recently, the largest trend has been fire. Fire is just devastating the West, the infrastructure, the forest lands, and in the case of the utilities, their lines built with wood. So a lot of the utilities in the West that have went through those experiences in the last, say, 15 to 20 years, one thing that came out of those experiences is a lot of their transmission lines were constructed with steel. So that created the transition of lower voltages. Rather than being replaced with wood, they've been replaced with steel and or concrete and or fiberglass. So we've been able to offer basically fire mitigation solutions in non-wood, and the utilities are going in those locations. So back to the discussion of weight, that kind of plays as well. A lot of the West has a different geographic than the South and Southeast, quote unquote, mountains, limited access, and things like that. So the lightweightness of steel and fiberglass is found probably a better place in those geographic areas where limited access warrants a lighter weight product.
Yeah, that does make a lot of sense, and that's that's something we touched on in the first segment as well, just with all the fires, and then of course that's happening up in certain areas of Canada as well. So it's definitely good to see an improved product in that regard. You actually mentioned as well, so that's actually a good segue into your fiberglass products. So that's being used for fire mitigation as well. But if you can unpack the full advantages of that side of your products, that would be great for the audience too.
Sure. So fiberglass historically has not been designed and applied for a fire mitigation, but in the last 10 years, there's been a lot of research and technology done to do that. So fiberglass is primarily fiberglass with a polymer base. So that's why it's referred to as a composite. So what we're able to do is then protect the surfaces with a fire, an additional layer of fire protection.
Okay, yeah, so that's good. So you touched on the obviously the concrete for those corrosive environments. You've got the steel, which have been an excellent, like for the utilities that are dealing with the fires. On the and going into the composites as well. Is there other use cases that you're seeing across the country or in certain areas, besides just in areas with the fire danger? It seems like those would have other applications as well now.
They do. They offer a lightweight solution. So the limited access environmental areas, a combination of water and just environmental areas in general. So there's many places in the country where wood is not readily approved, if you will. So there's a trend moving to non-wood products from the whole preservative treatment
Oh, okay.
that's in wood. So that's always an opportunity. The lightweightness is an opportunity. Another aspect of the whole fiberglass product offering composites is cross-arms themselves. So in a subset of what we've been talking about with poles, there's a whole nother activity that's been going on for 30 plus years, where the cross arms that hold the conductors that are mounted to the top of the pole,
Yeah.
those historically have always been wood also. So
Okay.
there's been a conversion from wood cross arms to fiberglass cross arms for nearly 30 years. So a lot of the industry from an application perspective, there's two different applications that I'll refer to, but fiberglass is definitely has a place in cross arms, which are on the pole tops to hold all the conductors.
That makes a lot of sense. And then they have that longevity. So yeah, so it was actually two different, it could be two different products a lot of times, because you've got the poles, and then you've got those cross arms. So you're dealing with are those all actually, one thing I would be interested in, do those get shipped out separately? So like when Valmont is manufacturing those, are they then assembled on site then as well, when you have those two different types?
They are generally shipped separately because they're produced in different facilities. So as Chris covered, we have many facilities doing many different materials. That same applies to the fiberglass part of the business. So those facilities generally provide product in volume and then ship directly to the use. Another aspect of shipping is cross arms are a much smaller scale items.
Mm-hmm.
It's more of a warehouse pallet type product, whereas poles are generally 40, 50 feet long.
Right.
So the handling, transportation, storage, deployment, all of that ultimately is a lot different. That said, we also do a lot of kitting. Certain projects will have both poles and arms, and whereas they might be manufactured separately, they arrive at the same time at the destination.
That's good. Have you, going into the use cases? Those are always interesting. On the composite side, is there one, like a project that stands out where somebody went to these as well and started using these, whether it was like the cross arms or the entire assembly? Has there been like some standout clients that you've worked with? Obviously, don't need to mention them by name, but that would just be a good way to tie that all together.
Well, again, the cross arms are pretty well accepted everywhere in the country now across many applications, geographies. The real driving aspect to that is there is virtually no maintenance to the arm. So what happens with both wood poles and wood arms is that they become a maintenance challenge, if you will, and then a maintenance investment. So arms definitely are all over the country. From a pole perspective, we have a lot of regional applications near kind of corrosive applications similar to the concrete. Whereas a customer seeking a more lighter solution, so they choose fiberglass over a concrete or a steel because fiberglass works very well in caustic environments. Another space is limited access. So national forest, BLMs, places like that utilities are challenged to be in and out of on a regular basis, meaning permitting. So non-wood products, fiberglass finds those types of applications often. So the utilities, once the project is scoped and scheduled, go in once for permitting. Generally speaking, they don't have to go back from a maintenance perspective. There's always an inspection cycle that happens, but from a maintenance perspective, they're not in there. So maintenance in itself is one of the benefits of the non-wood, if you will, engineered materials. Generally speaking, there's not a maintenance aspect to them once they're ultimately deployed.
Right. So that long-term value then they get when they actually install these is massive over the time, because you don't have the maintenance and you just have the inspection cycle, but the products are built to last for decades. So
that's exactly right. The change outs. So that's where the economics really start converting is over time.
Right.
So there's a cost entry difference to all the materials, but depending on how that's laid to the project and the scope of the project, there's material costs, there's install costs, and there's life cycling costs. So generally speaking, over time, all the non-wood products, that's where they really pay out over time.
Yeah, that's fantastic. Before we wrap up here and you get back to the show, So I just wanted to touch on like your background with Valmont. So you're vice president of distribution. How long have you been in that role? And just a little bit more of your background would be fantastic to
Sure.
hear.
So in the utility space, I've been in the utility space for about 26 years now, and I've always worked in the low voltage space of the utility space. And over my career with multiple companies, I've been involved in all the materials, both concrete, steel, and fiberglass. So I've been with Valmont for I'm in my 16th year with Valmont.
Wow.
Working with all three of those materials, but my real history in the industry is in low voltage, standard products, catalog products, etc. So, quote unquote distribution. So I've been in and out of all the materials across the country. My responsibility in product management is country responsibility, not regional responsibility. So myself and my group have our hands in and out of many regions, many customers in many of our regional sales groups. So what I often communicate to people that were first meeting each other, or a customer that is beginning the conversion path, they're moving from one material to another. One of the things that our group brings is generally the majority of their questions that they may have, someone else has already asked and answered. So that how we're organized, that works out really well. So we have scope to the whole country.
Okay, that's interesting because as you kind of move back, it's just not just one area. You're getting feedback from all the different segments.
We have many customers that use all three materials.
Right.
So from a use application, steel has probably the longest history and the most volume all over the country, whereas concrete is more near the facilities. But the smaller the concrete facility, the further away it can be used. So moving forward, we envision a lot of the industry, the utility industry, using more concrete, if you will, in further distances from manufacturing, because the product's smaller in scale, it's lighter in weight, and it just enables cost-effective transportation.
Yeah, it makes.
But they all.
Oh, sorry.
No, I was going to say from a large customer's perspective, many of them, meaning scale of the utilities, as Chris, summarized, miles and miles of both transmission and distribution. What comes behind that are many, 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 many structures. So in the distribution space, a given mile of construction could have anywhere from 20 to 25 poles. So when you put that number of units per mile, the magnitude of the materials and the demand of the materials is pretty daunting, frankly. So a lot of utilities use all the materials. Whatever works for them. A large utility will have a lot of geographic differences in their own without considering the Midwest to the West or the East. So it's interesting how they pick and choose what they need for their given application.
Yeah, so that's we're gonna be out of time here, so we're gonna have to wrap it up. But that's a really good point, and it's obviously we're gonna put the links to the products. We'll have the links for Chris and yourself, Danny, in the description so everybody can watch. I want to thank everybody as well for watching Building Energy. It's great to be at the Utility Expo this year, and looking forward to seeing the additional content. Please subscribe on YouTube to watch this episode and many more on Building Energy, and also, of course, follow us on Building Energy and Crowns and Partners on LinkedIn, and we will see you next time. Thank you.